how did we define the square roots of numbers when we first introduced them?
The thing that finding the number that if you times it by itself gives you the number that you started with.
Okay, now that's one way. So finding the number that when you times by itself gets you the number. Right, okay, so yeah, it's a little bit of a convoluted little definition, right? Like, the easiest way is to use an example. 6 times 6, 36. 4 times 4, 16, right? And then I presented to you at the beginning of this topic the problem that we have, and it's that we can't figure out anything that satisfies this one, right? Something times something that gives me -1. Can we satisfy that now?
Yes.
Yeah, what can we use? We can use I. But then in kind of the middle of high school, we sort of said, well, in actuality, any number should have not only one square root, it should have 2, right? What's the other square root that we could take? Yeah, so the negative of both of these, and that's because the nature of our numbers, right? When we put two negatives together, you do get a positive. So -6 and -6 also satisfy this. And so the same thing applies here. -I and -I, when you multiply them together, right, you're going to get, well, +I squared, which is -1. So you can see both of those satisfy that. Another way to look at it is that this is actually satisfying an equation, right? What's the equation that's satisfying? It's satisfying this one. Right? So the solution to this is z is equal to plus or -I, right? Right, so if you substitute that back into there, that's satisfied. The other thing we can start looking at is, okay, that's for -1, right? But let's go back to these ones, right? What if I wanted to find the square roots of the negatives of these, like the square roots of -36 or the square roots of -16? Can we do that now?
-6i times -6i.
Yeah, right. So you can actually start to see intuitively what this representation I allows us to do, right? It allows us to come up with square roots for these which didn't have real solutions before, right? You can just kind of, by observation, this is the first way we can look at the square roots of numbers, and in particular, the square roots of negative real numbers, right? The first way we can think about it is through observation. If we observe how we can represent I in this situation, then we can also observe the solutions to this. As Angus said, you can use 6i here, or you can use -6i, and they both work. And the same thing over here, we can use +4i, and we can use -4i. But can we generalize this? Yeah, we can. So the square root of any negative real number in this situation is just the square root of the value multiplied by I. Okay? And obviously we have kind of the positive and negative cases of that. So that's our kind of first observation here, right? The square roots of any negative real number. So if we have -a squared, what are its square roots? The square roots would just be plus or minus a times I, provided that a is some real number, okay? That's our first observation. The second way we can kind of think about this, and it's really valuable to think not just in terms of one perspective, right? We want a lot of different perspectives on the same situation so that we have a better understanding of this, right? So we can use this kind of theorem to work out the square roots of any negative real number now. We don't have to give it too much thought, right? Particularly if they're square numbers, we just essentially take the square root of that value, and then we can, slap an I on it, and you take your positive and negative cases for this imaginary component. The other way you can think about it is that this is actually satisfying an equation, right? What's the equation that's satisfying? Go back to this kind of situation here. How can we create equations where these are the solutions? How could we do that? What equation are these values actually satisfying?
X squared plus 36.
And equations usually have two sides. Equals to 0, right, okay. So with these ones, right, notice how there's no equations. You're only being asked to find the square roots. The other perspective is that, yeah, we're actually trying to solve an equation here. So for example, like Angus said, z squared plus 36 is equal to 0. You can think about it as z squared equals to minus 36. That's fine too, right? The reason why I prefer this one is because the way that we want to try and solve equations when complex numbers are involved is that we generally like to factorize or complete the square. So for example, this one, we're used to seeing the difference of two squares. Well, if I wanted to write this as a subtraction, what I can do is I can write it like this. Yeah? Now I've got two square numbers which are subtracted from each other. How do we factorize this using the difference of two squares now? Well, we go back to this. What are the square roots of something like this? That would just be z plus 6i or z minus 6i, right? And so that's how we can also get our solutions.